Okay, so continuing my instructions through this whole project, I have now taken the turbine features that I listed in my last video, and I selected these features. I ran the turbine through the plains, the hills, and offshore, and collected this data here. Now, some of it's more important than others, but some ones I want to point out right here are the watts produced. This is the amount of watts produced by my windmill at max capacity, right? This is the most amount of watts that it could possibly put out at any point. This number here, it is not the amount of energy that is actually being generated in the windmill. It's the max amount. I have to multiply that by the efficiency factor. This number here in row 7, the efficiency factor. So I take this watts produced and multiply it by the efficiency factor to find out the average number of watts that are being generated. And so not only are these increasing in the watts generated from plains to hills to offshore, but I'm also increasing my efficiency along the way, meaning that it's going to produce more power out of the most possible power. The watts per unit cost is a number I'm going to multiply by later on down here to figure out how much money it's going to cost for me to build a windmill. And then the homes powered is just how many homes on average can this power. Now, in Rhode Island, we actually use less energy in most homes than nationally. We're pretty good. Most homes use around 1,500 kilowatt hours per home. We use about 900 per home. So we actually do better in Rhode Island. So we're using the national average here. I didn't want to make things too confusing. I think this is far confusing enough. So when we get down to the calculations, I want to build a site that's going to power at least 2,000 homes. Now, what this means is that I might need more than one windmill. I'm definitely going to need more than one windmill. And the windmill that I made is terrible. It doesn't work at all. It's so bad. 163 homes, 187 homes, and 212 homes. So each one of these is going to require lots of wind turbines for this turbine to work. So the turbines needed for 2,000 homes, I just did in this box here. You can look up at my function up here, and I've got this function. It equals 2,000 divided by E9. Well, E9 is the homes powered. So 2,000 homes divided by how many homes it'll power. In this case, I'm going to need 13 windmills to hit that goal. And I have this roundup written in here first. Now, I didn't actually add this to my original copy of the spreadsheet. Right now, it's December 23rd at 1:12 a.m. If you are doing this after that point, it's already done for you. If not, you're going to have to go back in and add roundup and parentheses, just as I have them written here, to that box. And I can walk you through that in another video or something maybe, or I can do it right now. Originally, this just said that it said up here, it said equals 2,000 divided by E9. All I'm going to do, that's how it was when I sent it out to you guys. And if you look, it went down to 12. It was 13 because the actual number is 12.27, and that's the math it's going off of. But I can't use a quarter of a windmill, so I have to round that number up. And so what I do is I just come over here and I add round up and then put parentheses around 2,000 and E9, and that rounds it up. And then I just drag over from my magic little square in the corner, and it automatically updates the next two boxes. So you may have to put that in for yourself. You may be able to just download it, just use the new copy of the thing that I've got on the classroom now, and it should be fine. But anyway, this is the turbines needed. I need 13 turbines to hit those 2,000 homes. The watts produced, right? The watts produced right here divided by the price per, the watts per unit cost will get me the cost per turbine. So it's $1 million per turbine. Multiply these two numbers together, that gives me a total cost and a total amount of watts possible for it to produce. I multiply the total watts possible by the efficiency factor, here because it only gets 35.35 or 35% of the energy is used. So at maximum, I could have made 3 million watts. I'm really only going to get around 1,112,000 watts. And then this converts it to kilowatt hours per year, which is the way you buy energy from the electrical company. You can see the math right here. And then multiply that number by the current price. And I got this price from electricitylocal.com. I didn't actually check my own electric bill, but it's about $0.144 or 14.4 cents per kilowatt hour, of which I'm producing 9 million. So 9 million kilowatt hours times 14 cents gives me $1,403,000 a year. And then project that over 20 years, and I should make about $28 million off of this wind farm. But remember that it cost me 14 in initial starting costs. So I have to subtract that from 28, and I'm left with $13.6 million that I'll get in income from this wind farm. So when I compare these numbers, I can see that for my case, I'm going to say it probably makes sense financially for me to go with the offshore farm because I'm making a lot more money. It's way more efficient. I'm getting more of the energy that I want from it. And so I'm producing, even though it cost me, actually, it didn't really cost me, it cost me less than the costing here because this one needed 13 turbines and this one only needs 10. So I'm actually it's actually costing me less to start up. I'm producing almost exactly the same amount of total watts possible, but because of the efficiency, I'm generating more watts per windmill. And you add it all up, and I end up generating a lot more money. That little difference between the two is generating a lot more money for me at the end of this lifespan. So financially speaking, it makes more sense to do the offshore farm. So what I want to do now is I want to build at least one graph and one table that I can put into my document. Now, tables are easy. You just find some information that might sell your point. If what I'm going to do is argue the net income that I'm going to make, I just make a simple table. I can come down here and I can say location and net income. And then I can go ahead and copy the locations and the incomes. I can take these and Control-C to copy, Control-C to paste. I can just paste them in there, right? Why did these turn negative? I see. It's got a formula in here. So I've got to actually come in and just type them in. 13,620,464. 17,155,761. And 21640,447. And so now I've typed in those, and I think this was what? Plains, hills, and offshore. And then all I have to do is highlight all of this, and I can play with things like the borders and maybe change my borders around. Maybe I want to put a thick border around the outside of it or something. You know, you can get creative. Put a thick border around the outside. And then I'm going to put a name at the top, and I'll say Table 1, Net Income. And so then I can then copy and paste this whole thing, copy and paste this table right into my my PowerPoint. So tables are easy. You can also insert a table in PowerPoint and then just add your data into it, and that's fine too.